This video, we're going to solve some linear inequalities in one variable, and we're going to graph the solution set. We're going to do that by using the addition property of inequality here first. So 3x minus 2 is less than or equal to 6x minus 4x. So let's simplify both sides before we get started, just like we do with equalities. That's going to be 3x minus 2 is less than or equal to 2x. Just like with equalities, I'm going to try and subtract the same thing from both sides to get all my variables on one side, all my constants on the other, or add the same thing to both sides to get all my variables on one side and all my constants on the other. In this case, I want to subtract 2x to get my variables on the left. X minus 2 is less than or equal to 0. And now I want to add 2 to both sides. To get the x is less than or equal to 2. So the solution set is the set of all x's such that x is less than or equal to 2. This is the part that usually is the answer box in my labs. They'll usually give you the other part, but I want you to know what this means. This is the set of, is what these braces mean. And then it's the set of x's, because x was our variable. The vertical bar there means such that, and then you put a constraint in there. And this is called set builder notation, because it's up to you to build that set of numbers based off of the condition or the constraint that I gave you. Now I'm going to take that set builder notation and I'm going to turn it into a solution set with a graphical representation on the real number line here. So I have -10, -9, -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2. It could keep going, right? But I have less than or equal to 2. So I'm going to put a solid dot at 2. Let me change my pen color here so you can see what I'm doing. Solid dot at 2. And I'm looking at this x on the left, and it's less than. So I see an arrow that's pointing towards the left there. I'm going to shade to the left on the number line. I'm just going to do this with an arrow at the end because it keeps going, right? So when I reach the end of what I've drawn, I'm just going to say that this arrow here represents my solution set. Another way that I can represent that information that we're going to talk about maybe a little later is going to be called interval notation. It's going to be very important in pre-calculus to know interval notation. So I'll just go ahead and talk about it right now, that this lower boundary for this interval for my solution is -infinity. It's the biggest negative number that you can possibly think of, and then keep going because it goes on forever. And it has an upper boundary that is included, so it gets a solid bracket here instead of a parenthesis, and the upper boundary is +2. So this is called interval notation. It's important to be able to express your answers to these inequalities in both set builder notation and interval notation, and to be able to graph that interval on a number line with a solution set. If I didn't say so before, this is from section 9.7. That was one like number 19. We also got one like number 23 here, where we're going to use the multiplication property of inequality this time. Negative 5x is greater than or equal to 20. So this is where things get a little different than regular equations, because when I multiply or divide by a negative number with an inequality, I have to change the direction of the inequality sign. So because I need to divide here by a negative 5, I know that that would normally be x and this would normally be negative 4, but my direction of my inequality sign changes. So this is going to be a negative 4. I want to go to the left and I want to include negative 4. My answer is like this. I'm just shading because I'm using the same color so you wouldn't see my line on top of my other line. I'm going all the way to the left here. Here, let me draw it above the line. My solution set is going to go that way. So negative 4 is right there. My solution set is going to go to the left, which means that there's negative infinity for a lower bound, negative 4 for an upper bound, and that's included. And remember that your solution can also be expressed in set builder notation like that. All right, let's do one more. Of these before we'll do a couple more. There's just a mixture of addition and multiplication properties together. So I'm not going to go quite as slow this time. I'm going to divide by negative 1. That makes this y less than 0. So the set of all y's such that y is less than 0. There's my 0. It's an open circle or a parenthesis, depending on how your software shows it. And it goes to the left there, like that, for my solution set. And it's got open parentheses on both sides here because 0 is not included. I can get close to it, but I can't touch it. I need a number less than, but not including 0. So that one was like number 25 from the textbook. I'm going to do one like number 31 now. Negative 9 is less than x plus 8. Notice they wrote the x on the right-hand side to try and confuse me. I'm not going to get confused by it, though. I'm going to show you what to do. When I subtract 8 from both sides, I get negative 17 is less than x. I'm going to switch my inequality around here to say x is greater than. See how the big side of the inequality sign is towards x. So when I write the x on the left-hand side, I'm going to keep the big side towards the x. X is greater than negative 17. So this is my set of all x's such that x is greater than negative 17. Negative 17. And I want strictly greater than. So open circle because negative 17 is not included. And I want to go to the right since it's greater than. So in interval notation, this is going to be 17 to infinity. I have 7 times x plus 1 minus 6x is greater than or equal to negative 9. So 7x plus 7 minus 6x is greater than or equal to negative 9. X plus 7 is greater than or equal to negative 9. Let's subtract 7 from both sides, and x is greater than or equal to a negative 16. So this is the set of all x's such that x is greater than or equal to negative 16. Negative 16, we want a solid dot. We would want to go to the right. And that makes this a negative 16 for our lower bound, which is included, and infinity for our upper bound. This is the last example of this from 9.7. This one's going to be like number 45. Then I'll do a couple other problems that are from earlier in the textbook, and we've made instructor created questions from them changing the directions, but we're going to be doing that. We'll be coming back and just doing some more number line graphing. I'll do that in the next video. But first here, let's finish up this solving the inequalities here. So negative 4x plus 8 can be greater than 16 minus 2x. So we're going to add 2x to both sides. And then subtracting 8 from both sides. And then I need to divide by negative 2. And remember to switch the direction of your inequality sign when you do that. So that gives me an answer of all x's such that x is less than negative 4. Negative 4 is somewhere here. And I want answers that are less than it, so I get negative infinity to negative 4, not included. All right, that'll be it for this video, and I'll come back next time, and we will take some things that are written in set builder notation already, or that we have to solve, and we want to give the answer in interval notation, which is something I was doing this time, even though it wasn't in the instructions, but that's going to be specifically be the topic of the next video, is how to write these solution sets in interval notation. So if you're confused how I was writing it in interval notation, come back for the next video and I'll explain that a little bit more in depth. See you for the next video.